Hi, welcome to this course AI powered people counting system. Myself Muhammad Yaqub, I am the founder of ScratchLearn. In this people counting system, there are two problems we are solving. One is into the retail sector for improvising their operation management, and is that safety compliance improvement. For the retail sector, it is essential to track the people who are entering into the store. We call it as footfall counting or people counting. In retail sector, the footfall counting is the essential part. So we have to analyze hourly wise footfall counting, daily wise footfall counting, so that we can optimize the staffing at the stores in a better way. And also when it comes to safety compliance, when it comes to square feet of room, any kind of room, there are limited number of people should be allowed within the room. That is the safety compliance. To maintain that kind of safety compliance, we have to essentially count the people entering into the room and people living into the room. So this kind of safety compliance and then operational management, and also in retail sector, for calculating conversion ratio, footfall counting is the essential part, because if 100 people came into the stores, only 100 persons purchased, then conversion ratio is around 10%. So that for retail owners, business owners, the footfall counting is essential for calculating the conversion ratio, managing their operation, and then staying safety compliant with respect to the government. So this is the three major use case of people counting system. So people counting system. Thank you.
Now I'm going to give a brief introduction about the YOLOv8 algorithm. YOLOv8 stands for You Only Look Once, and this is version 8. It is an advanced version of the previous YOLOv7 algorithm. Accuracy, optimization, and inference time, these are all parameters that have been improved in the YOLOv8 algorithm, and it can be used for various tasks such as object detection and object segmentation. But in this project, we are specifically going to use it for person detection. With this person detection, we can calculate the number of people entering or exiting. Let's dive into the project explanation and execution. First, you need to go to the people entry and exit tracking folder, then open CMD there and type course start. Then it will redirect you to VS Code. Now, VS Code is open and these are the files we are going to execute. First, I'm going to explain the code for the project and then I'll show you how to execute it. First, we need to import the necessary libraries for implementing the project, which are listed here. CV2 sort is a technique used to assign a unique ID to each different person. And we also import YOLO from Altalytics. This is for dictionary, time system, AST and NumPy. Tkinter is for GUI integration. And then we import message box and file dialog from Tkinter, which are used for multiprocessing threads. Next, we initialize the sum of the variable. The variables are the in count and out count. Initially, both the in count and out count are set to 0. There are two options in the people entry and exit counting system. The first is top to bottom, which counts as in. Otherwise, bottom to top counts as out. And in another scenario, bottom to top is in and top to bottom is out. From this direction, we are able to calculate the number of people entering and exiting. The gap is initially set to none. When the program starts, we can fetch frames from the capture device. The tracker is initially set to none. After that, it can take on a value. The model is also initially set to none. Stop tracking is initially set to false. When we stop the exit process, we set it to true. Initially, the line coordinate text file is set to false. We should provide this information in the Tkinter window, and then the point is signed off the line. With this function, we can determine whether a person has crossed the line or not. We need to provide 3 arguments to this function. The first is the point, which refers to the person's rectangle point, consisting of the x and y axis. This refers to the starting point of the line's xy coordinates and the ending point of the line's coordinates. With this calculation, we can determine whether a person is entering or exiting. In this function, which is designed to access coordinate data from a txt file, we first need to read the txt file and then access the data inside the txt file. First, we need to check whether the data starts with NP array. If NP array is present, then we can access the data and store it as points. If none of the data in the txt file is present, the file does not contain any valid numerical array representation. If the file is not found in the folder, then we should display a file not found message. If there is no valid information in the txt file, then we should display an error indicating that the file could not be read. And then start tracking is a function. We wrote some of the basic functionality. Global is a variable that is accessed inside the function as a variable. Then initially choices is set to none. If no choice is selected, then we should display an error. Please choose the direction for counting here. Initially cap is none. You must select and edit the video file. Then load the YOLOv8 model. Then define the tracker. Max age is 30 and load the class names in YOLOv8, which contains 80 classes, but we are only going to use person. Then load the coordinates for the line. Then check the data type of the line coordinates and print the line coordinate data. Check whether the line coordinates are not empty. Then access the starting point and ending point of the coordinates and also print the data. Initially set the tag position as empty with a dictionary data type and also set the class ID to 0 at first, then create it as empty. The last count time is initially 0. We need to reset it after the person has crossed the line. The mean crossing time is initially set to 1. Then the program execution starts from this function, process, video. Initially access the in and out count variables using global variables. The program runs until the user stops the execution or the frame is empty. Then it processes each frame from the video one by one. If the frame is empty, we need to stop the execution and then store the xzone, yone, x2, y2 coordinates in the detections, which are the person's coordinates along with the class ID. After obtaining the results from the model, we process these results one by one here, retrieve the bounding box from the boxes variable, and then access the zone, yone, x2, y2 coordinates. Next, we access the class index and retrieve the class name. We will only proceed if a person is detected with a confidence score of 0.3. Then convert all of the coordinates to integers, store them in a numpy array, convert them into a vertical stack, draw a rectangle around the detected person's coordinates, and add text with the ID. After this, the information is passed to the tracker, which assigns a unique ID to each person. In this function, which draws a line on an image, we need to provide two arguments. One is the line start and end points, and the other is the color and thickness of the line. Then get the selected direction from the Tkinter window and calculate the midpoint of the coordinate line start, 0 data, and line n, 0 divided by 2. This is for the x-axis and it's similar for the y-axis. With this calculation, we can draw an arrow line to indicate either exit or entry. If the direction is 1, then draw a line from this coordinate, which means for the in count, draw the out count based on a bottom to top approach. Or if the selected direction is 2, then for example, draw an arrow line from the bottom to the top or from the top to the bottom. Next, draw a rectangle at the start and another at the end, specifying the top left corner and the bottom right corner. This approach is used to determine whether a person has crossed the line or not. If the person crosses the line, we initially at the very beginning define a rectangle in the CV2 graphical window for the in count, which as you can see is quite similar to the out count, and this condition is used to help determine whether people are crossing the line or not using the current time, the average crossing time, and the last count time along with their object ID. If the choice is 1 and the previous position is greater than the current position and less than 0, if this condition is met, then increase the in count data. Otherwise, increase the out count data. This logic is similar for direction 2. It's the same logic, but here the previous position is less than 0 and the current position is greater than 0. Then increase the in count. If this condition is not met, then the else condition will be satisfied. That is, the previous position is greater than 0 and the current position is less than 0. Then increase the out count. After that, store the value in the tag position along with their object ID, the stored box midpoint, line start, and line end. After that, simply update the Tkinter window display, then retrieve the current frame's width and height, and finally resize the window appropriately and accordingly. If the image resolution is too high, we won't be able to see the image properly. So that's why we need to resize the images based on the current frame. Then visualize the results. Then display the frame in the CV2 window. If you want to quit the program, you need to press the Q key. After that, release all process frames and destroy all windows. And this is a function that is meant to stop the execution of the program. And this is a function that is used to access a video file from user input. Then it accesses the line coordinates, takes a frame from the Tkinter window, then updates the count result in the Tkinter window, and then sets the direction. The direction must be either integer 1 or 2. The Tkinter window is a people counting system, and the height and width of the Tkinter window are 800 and 600 with a light blue background configured. Then the title is people counting system. First, we need to choose a direction, then set bottom to top and top to bottom as in and out. Top to bottom is in, bottom to top is out. First, we need to specify the direction, either one of these. Then choose a video file. Select the line coordinate file, then click to start, which begins tracking. There are stop tracking, in count, and out count labels. The Tkinter window continues running until it is used to stop the execution. Once the user stops, we need to terminate the Tkinter process. Next, I am going to run requirements txt file pip install our requirements txt, which is to install the Ultralytics library. Now it is installing. Ultralytics has been installed successfully. Next, I'm going to check the version of Ultralytics. In Python, import Ultralytics. Then type here Ultralytics dot hyphen Then type here ultralytics dot underscore hyphen version. The ultralytics version is 8.350. I'm going to show how to draw a line coordinate in an empty image using OpenCV. First you import CV2, then NumPy. Initially we fill the image so it's black with a height of 500 and a width of 500. Then the number of color channels is 3 and the data type is int8. First, we need to define the starting point of the coordinate, then the ending point of the coordinate. The color is blue. 255 represents blue. Then we need to set the other two values to 0. Then the line thickness is 5. This is the function used to draw a line on an image. Then this is for visualizing the image. And then stop the execution with 0 and destroy all windows. Next, I'm going to exit from this terminal. Then I'm going to run draw line, get this image path and Python file and paste it here. This is a line in an image with the starting point and ending point of the coordinates. And then the starting point should have an x-axis value of 0 and a y-axis value of 250 since the height is 500. Now I'm going to enter the starting point as x-axis 0 and 250, and then x-axis now 500, height is 250. 500 and 250. Next I'm going to exit and run it. Just press 0, then save and run. Draw a line. Now we've drawn a line in the center of the image. Finally, I'm going to run people counting PyP file. Before, I would like to let you know small information about input video. I have two set of input video, people input 1 and people input 2. Now I'm going to show how to get this starting point, ending point coordinate using Roboflow website. First, we need to go Roboflow. In the text box on your screen, carefully type the phrase exactly as shown. Roboflow polygon draw. This ensures the correct tool is selected for your annotation work. Next, we need to upload image in this drag image file here. Now, simply drag and drop. Next, we need to draw a line here. We need to draw a line using Roboflow like this. After doing line in an image, then need to get this coordinate point, then get this and paste it here. But I already have some coordinates, but not going to paste here. If you want to give custom video for people enter and exit counting, you need to follow like this Roboflow getting coordinate. Now I'm going to run people counting py. First you need to get this path, then copy the file, then paste it here, then run. It will first redirect to a Tkinter window. The Tkinter window is open now. First, I'm going to choose your direction. In means bottom to top. Out means top to bottom. Top to bottom. bottom to top in. I will select the first direction, set it, then click OK. Next, I'm going to choose the video file. Next, I'm going to choose the video file, then select this video and open it with its corresponding coordinate. TXT file, then open it and start tracking. Now the frame is currently being processed. This one is in and this one is out. And initially the count is 0 for both in and out. Now the person is going to cross the line. So the output becomes 1. And now the person is going to enter. So the in count increases to 1. The in count has increased now. Now the entire video frame has been processed, successfully completed. Then I'm going to stop tracking. Next, I'm going to provide another set of input. For that, we need to run the program. First, I'm going to choose a direction. Then I need to choose a video file, another set of video. Then select the coordinate text file here and then start tracking. Initially the count is 0. This one is out and this one is in. So far no one has entered, but they have crossed the line. Now people are starting to go out again, returning to public spaces and resuming their daily activities as life gradually returns to normal. The first person's out count increases, then the second person's also increases to 2 and the third person's also increases. The out count is 3. If you want to use any other video for people entering and exiting counting, you will need to provide a custom video file yourself or otherwise supply your own video. You need to create a new folder for that. For example, people input 3, and you need to get the coordinate file from the Roboflow website. You need to provide the video input. For that, we first need to run save image. If you have any custom video, you need to provide it here. Then the frames will be stored in the sample image folder. Before that, it should be empty. Then you need to upload these images to the Roboflow website, get the coordinate points and paste them here in the new people input 3. txt file. Now all the video frames have been successfully processed, and the output is 3 for out count and 0 for in count. I hope you have understood everything from my explanation of the project. If you have any questions about the project or the code explanation, just let me know by leaving a comment in the comment section.
Hope you enjoyed the course. Course will surely give you solid foundation in computer vision, and then it will help you on your final year projects also, and then surely it will help on your cracking your job interviews. While implementing this project, if you face any kind of difficulty while implementing the project or while setting up an environment, or if you get any kind of doubt, you can feel free to put in the comment section. We will surely help you in as soon as possible in a better way. Thank you.